Autotransformer reduced voltage starter calculations. In this presentation, we're going to be looking at the inrush current, starting torque, current on the line and load side of the starter, voltage on the line and load side of the starter, and the overload sizing for an autotransformer reduced voltage starter. In order for us to calculate these values, we are going to need to start with a full voltage motor start, and we need to know some pretty basic values, these values here, which have been calculated at the very beginning with a tutorial on full voltage starter calculations. If you're curious how we got them, go back to that tutorial. Now we're going to be using this motor with an auto transformer, which has a 65% tap. Now the 65% tap will allow for 65% voltage or line voltage to be applied across the motor. So let's take a look at this auto transformer at start and see if we can't work out some of the current values. Here's a simplified diagram of an auto transformer at start. I've only included a single line in there to try to clarify and to simplify the process. We have 600 volts coming in on the line side, and on the load side, we have a 65% tap, meaning that the voltage from here to here line value should be 65% of the initial 600 volt. Now, in order for us to calculate this, pretty straightforward, E line times percent, so 600 times 0.65 should give us 390 volts. The load side starting current. Well, the load side starting current is over here. We could call it the secondary current. And the load side current is going to be found by taking the starting current at full voltage multiplied by the percent that was given. So 134.71 amps times 0.65. This gives us a load side current of 87.56. That would be right here. The line side is a little bit different. The line side starting current uses the secondary VA as a starting point for the calculation. So we need to know what the secondary VA is because VA in equals VA out. VA in would be over here, VA out is over there. We're first going to calculate the secondary or VA out of this auto transformer section. In order to do this, secondary VA, we're going to take E line, I line, and root 3, our basic three-phase calculation. Now, E line, I line, root 3, 390 times 87.56 times root 3 gives me a VA, and this is the total three-phase VA of 59,146.76. This is the total VA that the motor is currently using. And we're going to use this in our transformer in order to calculate the primary value. In order for us to calculate that primary value, now what we need to do is take our VA and divide it by the E line times root 3. Now the E line over here is 600 volts and root 3 rendering 56.91 amps. In this way, an auto transformer starter can offer the same benefits as a primary resistor. However, it's more efficient because we're not losing watts due to heat, and we have a lower current on the supply side of the auto transformer starter. Let's take a look at what the value of torque would be for this starter. The auto transformer torque at start is calculated in exactly the same way as what we saw with the primary resistance. T start at full voltage multiplied by the percent squared, the percent given in the starter literature. So 65% voltage is what we're achieving, which means the total foot-pounds of torque is 94.55. Now, what about the current on both the line and the load side of this starter? We have some different things that are taking place due to a transformer being used, and we all know that a transformer, the higher voltage side, will render a lower current. So here we have the line and the load side. Let's take a look at start. During start, I would anticipate the load side to be higher than the line side. And so if we were to utilize the numbers from the previous calculation page, we would have 87.56 amps on each of these three conductors and 56.91 on each of these three conductors. So if we were measuring, we would not be expecting to get exactly the same value of current on both lines. During run, this motor is going to have a full 27 FLA or 27 amps FLA, and it would be present on both of those sides. What about the voltage though? Well, we have both sides of this starter. We have the line and the load side, and when we're looking at the motor starting, well, the line side should still be 600 volts, but the load side will be the reduced value of 390. During run, we would expect 600 volts being applied on both the line and the load side of this reduced voltage starter. Finally, what about the overloads? Remember that the overloads are always sized based on the value of current that will flow through them during run. On an autotransformer starter, there are only 3 overloads, and they are connected in the line conductors that supply the motor. This means that FLA will flow through them during run condition. This then results to the overloads being sized the same as a full voltage starter. And as we've seen before, that means we're taking the FLA, multiplying it by, in this case, 1.25 due to the service factor, giving us a maximum overload size of 33.75 amps.